Okay. Inequalities, for most part, are like equations, but obviously instead of the equal to sign, as you can see here, you're going to have the less than equal to, greater than equal to signs. A lot of the simplifying of an inequality is going to be the same, with the exception of in an equality, if you divide or multiply by a negative number, okay, so if you divide or multiply by a negative number, you need to change the direction of your inequality. If you're just adding, subtracting, nothing changes. If you're multiplying, dividing by a positive number, nothing changes. But the moment you multiply or divide by a negative number, the direction of your inequality has to change. So less than will become greater than will become less than. But before we get into solving these inequalities, let's talk about interval notation. The interval notation is this one here, where we're saying the values are going anywhere from 3 to infinity. So if your inequality, we are saying x is greater than 3. Which means we're saying x can be any number as long as it's greater than 3, right? There's no little equal to sign on that inequality symbol, which means x cannot be 3. But you can literally start at 3.000001, and it's going to satisfy this inequality, right? And we're saying if it's just greater than, that means you can keep going and keep going as large as the number will be.
But it can't be 3.
It cannot be 3 because you don't have that equal to, right? So that's why we're saying it's not including 3. So this is how we write our little interval notation. So just to show you on the graph, we are saying anything greater than 3. Remember, the number line goes to positive infinity on the right, negative infinity on the left. Some textbooks like to use open circle to show that here we're not including the 3 but everything else. Or some textbooks use parentheses to show you that, again, we're not including the 3 but everything greater than that. So we actually use this idea of parentheses to show that the 3 is not being included. But now, let's say if you were including the number, like this right here, x is less than or equal to 4, so we're saying x can be any value which is less than 4, but it's also including 4. So to show that it is included, you actually put a bracket on that number. So if it's parentheses in the interval notation, the number is not being included. If it's brackets on the number, it's being included. So literally just a symbol differentiation, which tells you what's going on. And then graphically, it's basically a closed circle or again a bracket to show you that that number is being included. Now this one we said less than 4, right? Which means we are going towards negative infinity. So you will again notice this right here, we're writing this as starting with negative infinity all the way up to 4, and then we put a bracket on 4 to show that they were included. So in interval notation, we always put the smaller number first and then the larger number. So look at that first set again. 3 is smaller than infinity. That's why we write 3 first and then infinity, because this is positive infinity. When we write negative infinity to 4, any negative number is going to be smaller than a positive number, right? Think about it that way. A negative infinity is smaller than 4. So again, we write the smaller number on the left, larger number on the right. And then, of course, that also tells us in which direction our numbers are going.
So we include infinity, but
no, we're not including. We've got parentheses around infinity and negative infinity, right? Is what you have to think about in terms of infinity. Infinity is not a number. Infinity is just telling us if it's positive, that means your number is just getting really, really large. If they can go into, right, millions, billions, trillions, bazillions, wherever your count is going. And then negative means we're going on the smaller side, right, on the negative side of our number line. So since infinity really is not a number like 3 and 4 are, we cannot put brackets on infinity. We never put brackets on infinity. So even though technically we're including it, we don't really put brackets on them. So the brackets will only go if your symbol has that little equal to on it. If it's equal to, put a bracket on the number. If it's just less than or greater than, you put the parentheses.
On the test, if we do like a closed dot or an open dot, is that acceptable?
Yeah, just make sure I can see that it's open or closed. Because some of you guys are not very good with handwriting. I don't know what yours looks like. I've never seen it. If you want to, your textbook in my math lab will expect you to do, well, I think they actually have you do multiple choice. Do they have you graphics or I think it's multiple choice. I think you're actually just selecting the right graph.
Okay.
So I don't think they have you draw, but if on the exam you draw your solution set, I'm okay with either or, but just make sure I can identify it's an open circle or closed circle. No chicken scratch. Because when you are solving an equation, you get 1, 2, 3, 4, depending on the equation, how many answers you get. It's specifically that number, right? So for our absolute value question, we got x equals 1/2, which means it's just 1/2, right? Nothing here, nothing there. Inequality is saying it can be any of these numbers as long as it falls in this way, right? So we're saying anything from 3 to infinity in this first one. So that means, like I said, you can start right after 3, right? Microscopic number after 3. So you can start at 3.0001, which satisfies, and I can keep going. I can do 4, 5 can be my answer, 10 can be my answer, 2015 can be my answer. So interval means you're saying any number between this interval is acceptable. When we did negative infinity, give me 1 second. When we did negative infinity to 4, including 4, we're saying it can be any of the negative numbers, but it also can be numbers from 0, 1, 2, 3, 4, and anything in between, and including 4, right? Which means I can use any of that. So interval notation is saying everything as long as it falls in this range of numbers. What were you saying?
I've actually seen like interval notation on engineering prints.
Oh yeah.
As far as like what the tolerances are allowed. What tolerances are allowed for certain parts.
Yeah, because even for measurements, right, for your tiniest microscopic measurements, they can still be within 0.001 centimeter, right? So it can go this way or that way. So you will see interval notation being used. And I'm just giving you one example, but yes, interval notation is definitely used quite a bit, depending on what application you look at. What else? Okay.
Yeah, we learned it was just set notation.
No, set notation would be what you're seeing on the left-hand side. That's so you guys never did interval notation? Okay. Well, I'll let you decide on that. But yeah, the bracket and the parentheses are just to differentiate if you're including the endpoint or not. So they talk about open intervals, closed intervals. So in this case, the idea of open is, of course, like I said, with infinity, we cannot put brackets on them because infinity is not a number. It's just telling us positive infinity, you're getting really large on the positive side, negative infinity, you're getting really small on the negative side. The open interval would basically mean you've got parentheses on both sides. I'm not including my endpoint. If it is a closed interval, then that means I am including my endpoint and you're going to have a bracket instead of a parenthesis. So closed, your open examples, and then of course, if your solution is going to be all real numbers, so we're saying I can use any number from the real number line. Doesn't matter if it's a fraction, if it's a radical, decimal, whole number, integer, everything is acceptable. That's obviously going to be an open interval because you cannot include infinity or negative infinity. So this first example here is actually giving you the interval notation, and they are asking you, depending on which form it is, to come up with this inequality. So what will that inequality look like if the interval notation is negative infinity to 5, including 5. Because of the bracket, right?
Oh.
So yeah, if that was a parenthesis, then we would have known 5 is not included. The bracket tells us it's included. So if you were doing this graphically, my positive infinity would be here, negative would be here. Let's say 5 is somewhere over here. And they're telling us your number is between negative infinity to 5, and you are including the 5, which means I'm going to the left-hand side of 5, right? Less than, and then for the equal to 5, again, you can do bracket. Some of you were asking about the closed circle, and I'll just show it to you above that. But that's kind of what your closed circle should then look like. Make sure it looks closed. Or you can use bracket and parentheses, whatever you're comfortable with. So what will that inequality be, which represents this interval notation? You're just putting the inequality, so you don't need to do the whole set notation. Just give me that inequality part. It's got to be one or the other. Less than or greater than. Very nice. Yeah, because they are saying it's negative infinity to 5, right? Negative infinity are values smaller than 5, which means, yes, exactly. You are looking at x less than or equal to 5. And again, why are we using that less than equal to? Because that's on the smaller side, and we've got a bracket on 5, right? If we didn't have a bracket on 5, you had a parenthesis, then you just wouldn't need to put that equal to sign, you would just have less. So the bracket is what's telling us do the equal to and the less than.
So it's the x is less than or equal to 5, that's right.
That's your inequality? Yeah, that's all they're looking for. Okay. Okay, so this is kind of what I was talking about when you are multiplying or dividing by a negative sign. So if you look at this property of inequality box here, if you're just adding or subtracting a number to each side of your inequality, the symbol does not need to change. But if you are multiplying by positive, that direction stays the same. If you're multiplying by negative, you will notice from the original, the direction of my inequality has changed. If you are dividing by a positive, the inequality symbol stays the same. But if you're dividing by a negative number, the direction of your inequality will change. It's very, very crucial that you remember this. So looking at example 2, you're treating it like an equation, but just remember about that multiplication and division by negative. Where would you start on number 2? Yeah. Are you talking about that negative 2 on the outside? You can distribute that inside the parentheses. Yeah, very good. So what will that end up giving you? So yeah, distribute that. And Iram, you said? Okay, what are you missing? Very good. Negative 6x and then positive 4 greater than equal to 4 minus x. Okay. Again, like I said, think of this as an equation. So what would be our next move? Subtract 4, very nice. And what will that end up giving us? Yeah, because 4 minus 4 will cancel out on both sides, leaving us behind with negative 6x greater than equal to negative x. We have an x on each side. How would we do that? Yeah, either add the 6x or add the x. It doesn't matter, but the idea is you need to get both the x's on the same side.
of your inequality. So which one are we doing? 6x? You just added the x? Okay, let's do that because then I can show you what happens with that negative sign. All right, so you are adding x. If you want to avoid the negative sign, move the 6x, okay? But this would be good. Negative 6x plus 1x. Negative 5x greater than equal to 0. Very nice. All right, so this is where we need to now get x by itself, right? So to get x by itself, what would we do? Very nice. So now we are dividing, but dividing by a negative number. So since we are dividing by a negative number, direction of your inequality has to change. That's the only difference between an equation and an inequality. So these guys cancel out. I'm left with x less than equal to 0 divided by negative 5. 0. So if this is our number line, positive infinity, negative infinity, 0 would be in the middle. What direction are you going? Yeah, very nice. We are going left. And what should I put on 0 itself? Close circle or? Very nice, yeah, and you're always facing the direction you are in. So this is going to the left, so you can do that, or if you wanted to do the close circle. Obviously, make sure it's on the line and not floating above. That's just me showing you the two different symbols. So if you wanted to do it that way, you can do it. And you can do close circle, going to the left. Either or. So this would be the inequality. This would be the graph. What would the interval notation look like? Bracket on?
Bracket on the right side, parentheses on the.
Yeah. Positive, negative, infinity, doesn't matter which one, always parentheses. And then since our inequality symbol has the less than equal to, that's why you're putting the bracket. But interval notation, you do have to do brackets, right? There's not the option of the closed circle, open circle kind of thing. That's just for brackets. Okay, just keep that in mind. All right, question on number 2.
You're always going to flip the side of this negative if you're dividing the negative.
Dividing or multiplying by negative. Yeah. Very good. Okay, so compound inequality means you will have two of these inequalities separated by the word and or. So sometimes you can have these three-part inequalities, which are actually a version of the and inequality. So in this case, you're sandwiched between two numbers, right? So instead of going all the way to infinity or negative infinity, you can be between two numbers. So then it actually depends, are you including both your endpoints, one of the endpoints, or none of them, right? If you're not including any of the endpoints, that's an open interval, that's what your graph will end up looking like. If one side is closed, both sides are obviously included with the equal to in there, that's your closed interval with the graph like that. But now these guys are, again, half open, half closed, however you want to look at them. One side is included, the other side is not, so then your graph would reflect which one's included, which one is not.
Half open, half closed. Would it matter? Is it going left or right? So let's say the bracket with the closed, would we read it as that would mean closed and this would mean open?
Yeah, so that means you are actually including the A value, but B is not included. Or in this case, A is not included, but B is included.
Would we specifically have to write it in the order that it is?
Yes. Smaller number always goes first in your interval and then the larger. Yeah. So that order is crucial. What else? Anything popping up right now? No? Okay, so this is what I was kind of talking about with your compound inequalities. They can be separated by and or, which actually dictates what your graph is going to end up looking like. Because if it's an and, then you are actually sandwiched between two values. If it's or, then they're actually going to be going in different directions. So we'll take a look at that next time. So we'll start here with our intersection and union of sets. So here's what I'm thinking for Wednesday. I was really hoping to finish this today, but that's all right.